want to start by sharing the statistics. I don't know if you have seen it. A recent survey from Gartner said that 42% of respondents said they don't understand the benefits of AI and ML and how the benefit that AI and ML could provide for their businesses. Now, why do you think that is? We've heard about skepticism, which is true, but also mostly due to our next slide, which is a statistic recently in 2021 that said that even for companies that have adopted AI and machine learning, what is happening is that 90% of the solutions, they don't make it to production. We all have friends. So when we talk to each other and we say, we have not been able to deploy anything into production, then the fear that the other people have to actually embrace this technology is heightened. It becomes a huge problem. But why is this happening? Why is it that about 90% of data science solutions don't make it to production? Maybe you work in an organization yourself and I don't know, a year and a half, and you don't even have one solution in production. So when people cannot really realize the benefits, then it's very difficult for them to embark on this journey with you to embrace this emerging technology. So why? There are some of the reasons next, to the next slide. Now, some of them is difficult to control. Some just has to do with mindset. And some of them can be very philosophical. We could probably talk about some of these for a long time, but there are some of them that could be solved. But these are some of the problems. For instance, we sometimes don't have access to data. And when we do have access to data, there are quality issues. And when we try to fix these quality issues, it takes us a long time, even if we are very experienced data engineers. As we work in a team, there's disconnect between teams. IT, data science teams, ML engineers, we are not able to work in tandem. There is a lack of scale personnel. Unicorns are very difficult to find. And some of these unicorns, we are also competing with these big boys or big organizations. And the unicorns have their own mind too. You know, they want to work with the likes of the Googles and the Amazons. And so it becomes very difficult to sometimes retain them. There are platforms out there that are difficult to integrate themselves into the tech ecosystem that we have in our businesses. The processes are asynchronous. We start experiments and we never complete the experiment. We keep running pilots here and there. There is a lack of cross-language and framework support for building some of these applications. We are not able to retrain them. We're not able to reproduce the results. We're not able to put in place proper versioning control. Lack of ability to update the models. And in fact, when we try to do some of these, sometimes it takes us about 6 months. It takes us about 1 year. And we have a team of maybe 15 members working on a particular project. So these are all huge problems. Now, some of them, like leadership support, might just be the culture of an organization. But sometimes it's also because we have not been able to implement anything in a while. And so now they begin to pool the resources. What is one of the solutions, or what can help us, is in our next slide. And that is MLOps, machine learning operations. Now, when we talk about machine learning operations, there are a lot of definitions for them. And most of us are probably familiar with this. The development cycle, or the development of a machine learning solution, can be very complex, from data ingestion to data preparation to model training to tuning models, model deployment, monitoring the models, explaining the models, and so on and so forth. It needs a collaborative effort between teams. There needs to be handoff across teams, from data engineer, as an example, to data scientists to ML engineers. Now, naturally, the development lifecycle requires a stringent operation rigor to keep all these processes synchronous so that we can all work in tandem. And that is what MLOps encompasses. It encompasses the experimentation, the iteration, and the continuous improvement of the machine learning lifecycle. So if you have MLOps in place, then you will be able to create solutions, machine learning solutions, not just create solutions, but the quality of the solutions that you create is such that everyone will be able to support it, and there will be advocates, there will be users of them. By adopting these MLOps approaches, we as data scientists and machine learning engineers should be able to collaborate, and we can increase the pace of model development and also deployment into production. It will help us to do things like continuous integration and continuous development. We'll be able to embrace these practices, properly monitor, validate, and govern the models that we build. So on a life cycle development, which is our next slide, I just wanted to show you some of the things that happen. What are some of the components of machine learning operations? If you look at it, you can see that sometimes we can be focused. It could be focused such that it's only on, let's say, deployment, but it could also be expansive such that it covers everything across the pipeline from model data ingestion to model production, right? Now, if you are implementing MLOps, then the process will sometimes be dictated by how big or small the project is. But in our experience at Braintoy, what we've realized is that MLOps cut across, especially when you're working with enterprise organizations, the principles of MLOps cut across data exploratory, analysis, ingesting your data, preparing your data, engineering your data, which is called feature engineering, training your models, governing your models, tuning your models, which is called parameter tuning, gaining inferences from the models, serving the models, deploying them, monitoring the models, and even retraining the models, which is part of optimizing your models. Now, one of the main reasons why you would want to have this, or at least for us in Braintoy, is so that we can ensure data consistency across the pipeline. So if you're a leader or a data scientist working, these are some of the things you would have to look for. But that is not all. The components include things like embracing the CID. Next slide, please. Embracing the CI/CD pipeline, which is borrowed from DevOps. So in addition to you being able to work in tandem with your team, collaborate, you need to be able to commit changes. As an example, have a code repository. Are you able to trigger when there is going to be a build? And when you build it, are you able to notify people of the outcomes? Are they able to review them, as an example, so that they can give you some constructive criticism, so you can avoid unintended consequences? And when the reviewer is also complete assessing your solution, are they also able to notify you back with comments, perhaps for improvement? Now, when you want to deploy your model, how long does it take you? Do you need a team of skilled experts to do this? Does it take you 3 months, 6 months to be able to serve? Now, what about when the model is also in production? Are there thresholds for decay? Are you able to detect decay automatically, so that you will be able to flag it, you'll be able to report it, you'll be able to fix it, update it, and get it back across the pipeline to integrate into production systems, whether they are new or they are legacy applications? These are things that needs to be in place if you really want to have a good machine learning operational, good machine learning MLOps implemented in your organization. Now, next, it goes beyond that. It also means that you need to be able to schedule things. So as an example, am I able to, when there are new data, am I able to refresh the data? How long does it take me to apply the existing data engineering formulas, functions, techniques, algorithms that I applied to the new data? Are you able to save recipes and reuse them? Now, if I can notify other people, especially if I have a governance process in place for them to help and support me to review before I put it in production, am I able to document all my assumptions as a scientist, a data scientist, or an ML engineer? What algorithms did I use? What are the parameters? How did I tune them? Now, especially if you're a leader, if one of your team members leave, do you have this such that it could be reproduced? Are you able to retrain your model, as an example? If you have all of this in place, then you are confident that you can build solutions that your customers can love and trust. And it will not take you a long time to actually deploy solutions into production. And so this is our next slide. Realizing that this is the key, or MLOps is the key to helping us build production machine learning, Braintoy set up on a journey for years, and we have built something called MLOS, the Machine Learning Operating System. It simplifies the complexity in the development lifecycle. It's able to foster teamwork. It's able to, in a nutshell, help you to build solutions that your customers can love and trust. Now, we always talk about low code and no code, and this is really key. But when we mention low code and no code, then expert machine learning, experts who want to write code want to shy away from it. They think that this is not useful. But please, today, I'm encouraging you to embrace it. Because low code and no code does not mean that you, as an expert, cannot write your code and solve complex problems. Low code and low code simply means that we're simplifying the process and the technology so that people with domain experts can also express their domain knowledge in building solutions. If you take supply chain as an example, a supply chain professional may never be an expert coder, but they have all the domain expertise in supply chain. An expert data scientist may never be an expert supply chain professional, but they also have all the expertise in data science. So if you can have low code and no code, then you can empower the supply chain professional to express their domain knowledge in building solutions. And the data scientists can also build complex solutions and pass that on to the domain experts so that they can continue to update, to upgrade it, and to solve other meaningful problems. And the data scientist who has acquired knowledge years in building ML solutions, can now spend time to do the things that are fun, solving complex problems and building tools that can make it easy for everyone to adapt AI. So next slide. We've always said and we've always heard that AI is the next electricity, which means that we have to empower everyone to embrace it. No one today can function without electricity. No industry can live or can compete without electricity, and no individual can even function. So if we are going to be able to scale it, then we need to empower domain experts to embrace this, not just empowering unicorns, because the unicorns are difficult to scale. They are even difficult to come by. So the advancement in low code and no code machine learning platforms has made it, or is making it easier for everyone to harness the benefits of machine learning to solving problems. So today, I implore you to get on board, both experts and domain experts, and let's embrace this technology and begin to use it in solving meaningful problems. Now, what are some of the problems that you can use it to solve? I will pass it over to Dr. Padma Paul, who will share examples from energy industry, from manufacturing industry, real life examples that Braintoy have worked on with organizations. And perhaps it will get you thinking about some of the use cases you can also build and solve in your organization to increase profitability, reduce cost, and improve efficiencies.
Thank you, Kwame. Really appreciate that. Okay. So I think we already talked about the benefit of using MLOps and in the production machine learning. So I will talk about three use cases that we solve for our clients. One is in oil and gas client, another is in manufacturing, also another is the uh, uh, energy sector. So if we think about a problem with, let's assume that we have 200 wells and we have to use 7 different variables for each well. We can think of like 14K models we have to build. Now we may have a 15 plus data scientist teams and some domain expert, and maybe we have allocated time and millions of dollars, but still the project risk is very high. And the on demand updating the models, and maybe you need to retrain the models, 14,000 models in every 3 months. It's a complex and a huge problem in there. Now if you think about the problem for those clients, what we have actually is too many tool to manage for this same problem to solve, and maybe some very advanced code required, as the MLOps with low code and no code environment, or maybe in a like a large scale environment, maintenance can be very difficult. So what the solution for this like problem to manage like tons of models can be optimized by, the automatic data pipeline building, recipe creation for data wrangling, or a feature extraction, recipe creation, and also reusability of the previous course, maybe for project to project, or maybe well to well, like engagement. And there should be some scheduler kind of things that can actually schedule your complete process, that okay, whenever the new data retrieved, I will like to apply this recipe, I would like to do this. So you can actually architect the whole MLOps without writing a single line of code, with using the templates. So I just want to go just with some of the screenshot maybe for how this MLOps problem, or the huge problem with thousands of models, can be solved. Uh, so this is a like a, you can take a screenshot of MLOS we're talking about. What we have actually, these are the like the steps for complete MLOps. So data engine, where it can, the bring data and prepare all this data for next step to the machine learning, governance piece, and also the deployment piece. I don't want to go beyond anything, but I just want to show how these things can be done. Also, there might be some job scheduler and some custom variable store, or variable store like a data lake you can think of, where the new data flow will happen. And then you may have like thousands of wells that are loading all this data over time, and that can be like you may have tons of models that can be created. And you imagine, for 14,000 models that we are talking about, it's not only just 14,000 model. To get that 14,000 model, you may need to do so many other testing, and maybe there are so many permutation and computation of parameters for each of these wells, because wells are very like the diverse, and it's really hard to optimize a single model for all the wells. So you may have to go for a like individual well basis solution. Now, if I go to the next step, you can also bring all your code, or you can write all this code and then combine them together with the same MLOps or all these schedulers. You can write your custom codes and everything on that, like to prepare everything, even the dashboard and things like that. And also, once it's deployed, it's managing those deployed model is a nightmare. So this is where the complete plug and play MLOps modules comes. So you can schedule a job. Let's say, hey, every 3 months I want to retrieve new retrieve new data and to build new model. I want to send the feedback to the ML pipe, so that in each and every step I can modify them. I can have different recipe, different sets of recipe, bring it over time. Like you can just name it. So the way we solve this crazy problem with uh, like thousands of model is by scheduling and from the template, where you can actually retrieve new data, apply those recipe, and depending on the well tags and pi history and data, you can think, um, you can just build a data set, and from those data set models are built. Also, there might be some um, you know uh, like governance process that's also automated, maybe email confirmation that, hey, this is the performance and there is a challenger model. Should you do you want to accept that or reject it? So you may just, on the mobile, you can just say, yes, I want to go to the deployment. It's like that's automated, for so that a smaller number of team members can actually manage a large scale project with MLOps. Now, if I go to the next problem, which was in adaptive manufacturing, and this problem is not with the like it's a different kind of data. You can think of like we're capturing data from the cameras, where we're monitoring how well this malt building is happening. So every camera that's they were actually, for every project, they were retrieving all the data and putting into a like storage bucket, and MLOs can retrieve those data from the storage bucket, and there's so many types of features for those images or videos, like shape or maybe the gradient or texture or transformation based features. And there's a 12 different scenarios, and you can think of hundreds of the operations are going on every day, and you may need to upgrade it every week or maybe every month. How to handle those thousands of model in computer vision, where you need huge GPU computation power and optimize the cost for your infrastructure, and all these problem map together to solve this problem. So we also built a annotation engine where the automated annotation can be done from the data retrieval process. Like, you retrieve the data, you do annotation for those image data or vision data, and then you can, again, with this ML pipe, you can push those new annotated, retrain those models, put it to the production, and then optimize your risk, also optimize your production time. This is the second use case that we one of the vision use case that for one of our clients. Another is I can go move to the next one, which is a green energy client. That's also a vision problem. uh, uh, so what we did, actually, we fly drone for the solar farms. In these solar farms, we're trying to detect the faulty solar panels. Like, when you have a like a actors of solar farms, like one person or 10 different people, like, they cannot go and check one by one solar panels. We need some automated process. So we're flying the drone fly through the solar farm, and it goes to its base and offload the data to a server. There's a connectivity in place. Once the data is offloaded, the the background scheduler, background process manager can actually process all the data and generate a report, and then pass it to automatically to the maintenance team, and they can go and with the row and column where to go, replace those solar panels or change those solar panels. All these things can happen. All right, then I will move to my next slide. Maybe this is just an example. You can think like, when it drone or flying, it's actually detecting each of these cells and then trying to find, hey, this is where we are having some issue and things like that. Okay, I will ML ops with all this solution and all these pipes that we're building. Um, these are actually plug and play. The problem with current industry, Kwame was mentioning, you can think of like sometimes we rebuild some solutions. That's in MLOps, that becomes a crazy problem, because one data scientist, they work such a way, maybe has so many versions, and those version controls and inconsistency, that becomes a like lengthy time for any solution, right? So this is where we can do, like with even with the domain expertise without coding experience, they also need to manage all these MLOps issues. So yeah, so we can use MLOps to solve the crazy problem that current industries are facing. I think we should move to the question and answers. Um, let's get back to, if we can have any option here to answer the questions.
Cool. Awesome.
Yes.
Thanks, Pat. So I will bring on one of our volunteers, Joel, to ask questions on behalf of the audience. And yeah, let's get those questions flowing.
Hi, good morning.
Good morning.
So we've
Good
got a
morning.
couple questions here, guys. The first question looks like it's from Yan, and they have asked, what is the goal of the oil and gas case? I think that was case number 1 you guys presented there.
Okay, so goal was to in oil and gas production, like, you want to monitor the complete well. So you want to see the production, you want to see the pressures, you want to see the downhole temperature, if there are any risk happening, the health, safety was one of the risks that we're looking at. Also the production, maybe water production. For each well we had around 6, 7, 8 variables sometimes. And yeah, so we wanted to optimize all these variables to give the better ROIs in the business.
That's great. And then we have another question from Nancy. She asks, can MLOps run in cloud like AWS or GCP? And how does it differ from AWS SageMaker or GCP Vertex AI?
Okay, so that's a really fun question for me. Love this question. So so you need to think about the expertise over there, and also how complex problem you're working on, and also think of a like in-house production, or the cloud, hybrid cloud, what kind of cloud you're using. Most of the organizations, oil and gas organizations, sometimes they have so many in-house, and transforming them from the in-house to the cloud is one of the most difficult piece. And this is like, you can think of a direct interview with the clients that we got. So when they want to move all their, and they have age system, right? They everything on the edge, they want to run something on the edge, and there's something on the remote areas. So you can't go with the like tons of bandwidth over there and then run those process in the edge or minus 50 degrees Celsius or minus 40 degrees Celsius. There's not even internet connections there. So think about those kind of situation. And so this is a, you can ML ops using like if you think like low code no code things. And also in that area you don't find so many advanced users. They'll be managing all these things. So the field itself is actually become your cloud at that time. It's just an isolated cloud, or I would always name it as a local cloud, or the way local network works. Now over there, this connectivity is not there. MLOS or low code no code is actually solving the problem with both that connectivity issue and the expertise level issue and the remote issue. So you see, that's where we're like this is how it's different actually.
And
I
I
mean,
would
if you
like
have
to,
something to add, yeah.
yeah, I'd like to add to it. So yes, we MLOS is actually cloud agnostic or environment agnostic.
Mhm.
So it deploys on GCP, AWS, on-prem. Padma was talking about Edge, all of that. Now, how different it is also is that most of these technologies that we find right now, and you mentioned some names, they are geared towards helping really experts build models. They also try to simplify it, but they are also for one-off solutions. What I mean by that is you build one solution and you really have to make an update or make changes. How long does it take you? There are also some of these technologies, for instance, that you mentioned in AWS, and it's just too cumbersome because there are different pipelines for every single tool that you want to use. So every time you want to do a single thing, there's a huge learning curve for you to be able to adapt it. MLOS takes all of this away. It's a single pipeline, irrespective of what you are doing, irrespective of the data you are working on, from vision to natural language processing to tabular data to multivariate and univariate time series. They are also not for one-off solutions. You can build, scale, monitor, and deploy thousands of models. Your iterative process, and we have people who have used it. And if anyone is on the call, you can actually type in there, because we have people who have switched from some of these big boys into using us, and they testify to the amount of time it takes them to deploy models into production now, and how drastic that has been reduced from months to days and weeks. So these are some of the differences, and you can contact us later on if you really want like a demo. We can demonstrate it.
Mhm.
Wonderful. We have another question from Hassan, who asks, which type of industries are more accepting of machine learning solutions? From the examples in the conference, so far it seems like renewables, i.e. wind, solar, are more inviting to these methodologies.
Mhm.
Okay.
Yeah, you can think of like every industry. I would say this way: like if there is data, there is AI. There's need of ML there, because without AI ML, there's nothing you go inside. So data actually proportional to the AI ML. So I would say that way. No matter which industry, generating data need AI ML. Yes, wind farms, like the green energy, we're looking at those. Also energy sector for sure. Manufacturing is also like really interested in AI ML, because the problem, they're doing it in a manual process. We could not actually show all of our use cases. One of the use cases we're working with the Germany, that's where the assembly line. So they're actually assembling a train door. You can think that way. Now, when they're assembling the train door, the biggest challenge they have, there might be one or two screw missing somewhere. And when they go with that door, and then the train compartment they have, if one of them come up with that fault, they have to change the whole like train compartment and revisit the whole process. Now it sometimes the cost is similar to the building the same new thing. So this kind of situation, like it's a matter of one person fault maybe, or one pipe fault. Now if there's a second eye or third eye or fourth eye, there's a looking at their assembly line and then saying, hey, you missed this step, or hey, I want to validate if whatever I did, is it okay or not. So even this assembly line operations, they're using computer vision or other like data, unstructured data, to solve this kind of problem. So I would say like smartness or automation, wherever there like rigorous work needed, they're trying to automate it and utilize the skills to other sector. The same skill they're trying to utilize the other sector. Comment if you have something to add.
Yeah, and just to add, so it is true that renewable energy and those, but also oil and gas is beginning to embrace this technology. Utilities are beginning to embrace it, and it's very useful. Insurance, financial services, they are beginning to embrace it, and we all have to. To Padma's point, if you generate some data, you definitely have to. It is true that it's taken some organizations and some industries a while, but they are beginning to rethink, and this is a step in a positive direction, and they have to, because otherwise, as I think it was Elon Musk that said, if your competitor is rushing to build AI and you are not, they're going to crash you. This is inevitable. So we know it's expensive. We know it's confusing. It sounds like confusing. It sounds like it's expensive. We don't know where to start. But irrespective of your industry, look for the right experts, and they will be able to help you adapt and embrace it.
Mm.
That's a great answer. Thank you. Last question so far is from Zara, who asks, for this oil field example, what is MLOS, the difference between IoT cloud solution?
Oh, okay. So yeah, thank you for asking. That will also solve some of the confusion. So the IoT cloud solution, if you think that way, it's like a when you are moving data and doing machine learning, you have to use machine learning anyway whenever you're moving data to the cloud. Like maybe your sensor is smart. Our future goal, if we think of the vision, our plan is to put this MLOS to sensor level. So we want to go that level. But so the smart sensors, soft sensors are in the field also, beside the original sensors. Uh, with the well field example, let's say you have your complete cloud infrastructure there. You can take all your computers there, like the servers, and you can build complete solution over there. And maybe monthly or like weekly, you can upgrade to the maybe the head office and things like that. So it's like bringing the data any way you need ML there. So that's how it's a complete platform versus a particular like one solution to a data movement from the sensor to the cloud.